All right, hello and welcome everybody from wherever you're dialing in today. It's early here in the Mountain Time Zone in the United States, but I'm excited about this conversation. I've been looking forward to this since it came up on my calendar for quite some time. We're going to talk to our friends at Heroic Labs today about what they're doing in terms of building kind of scalable backend architectures, and a lot around data, but some things around some other things that they're doing that are really kind of special here. But a little housekeeping before we get started. First of all, yes, definitely. A recording will definitely be available after the event. The team is pretty good about getting this up on our YouTube channel within oh gosh, I don't want to give an SLA, but an hour or so. Please do ask questions in the QA panel. That'd be great. We'll try to log questions in as we go along. If anybody wants clarification on something we're talking about or has a question they need or engage in chat, I'll be monitoring both along the way. And taking part in the conversation. So please do join us. You're already on the call. I hope this is an intriguing, great conversation for you all and valuable. I know how important it is, your time, I know how important time is. So today's session is somewhat intermediate. There's going to be, I think it's a beginner to intermediate. We're going to talk lots of things here. There's a couple topics I love to talk about. I love to talk about open source. We're going to talk about Heroic Labs and what they built. And we're going to talk about scale and what that means to applications and some of the challenges that the team has had. So with that, I want to welcome my guests on. So Chris and Tom, do you want to come on video? Awesome.
Hi, guys.
Hey, guys.
Hello, Chris and Tom. This is a truly global event here. We've got London and oh my God, I almost said
Edinburgh,
Glasgow.
Scotland.
I almost said Glasgow.
Close enough.
London, Edinburgh, and Denver all on the line here, everybody. So good morning, guys. Thank you for joining us. Let's just do a quick round of introductions. Chris, do you want to just give me a little bit about your background and
Sure.
what you're doing there at Heroic Labs? I think it's a little bit of everything, I think, but
Yeah, I mean, I was one of the founding engineers. Been with the company now 7 years. We've been 4.5 years as an open source company. So we can always talk about why we made that change because it could be quite interesting. And then prior to that, I worked in a bunch of database as a service and database tech product companies prior to that. So that's
right. And I'm sorry, how long has Heroic Labs been around?
I've been about 7 years,
Okay.
but about 4.5 years as an open source company.
Right. Okay. Yeah. I mean, it's a long time, buddy. That's startups are not easy.
It's a big journey. Yeah,
it is. So, and then Tom, do you want to give a quick introduction as well?
Yeah, can do. So I joined Heroic. It must have been about eight or so months ago now. So I'm an engineer, and yeah, my history is sort of back-end engineering work. Joined Heroic mostly to tackle some of the sort of developer onboarding experience and try and boost what we've got there to help the development experience be a little bit smoother. So yeah.
Right. Yeah, those are big problems to challenge. Those are big problems and challenges. We see it all over the place.
Absolutely.
Not simple stuff. Meaty, fun problems. I like meaty, fun problems personally. So
yeah, absolutely.
Chris, why did you start Heroic? What did you see? I mean, you were at a database company, so it's kind of a little bit of a jump to get from database to gaming backend, dude. Is it? I don't know.
Good question. So when I was working at the database company I was at the time, in fact, there were 2 generations of database company I worked at. We ended up working with a lot of game studios. We worked with a lot of players in this space, Rovio Entertainment, Riot Games, players like that, trying to solve the scaling challenges they were facing, usually around big social systems, social gameplay, maybe real-time chat-based problems where you have to do chat persistence and channel messaging and things like that, and how to handle that when you're dealing with 200, 300, 400,000 concurrent players and hundreds of millions of player accounts. So that is what drew me into that problem space. And then I thought, you know what, I'm seeing these patterns of problems over and over again. Maybe there is a way to solve this in a piece of technology that's more general. And that's what led us to Heroic. Yeah.
Yeah. So, I mean, taking the kind of platform or server approach to solve those problems, I think we've seen it done time and time again. You see the same thing emerge over and over. My personal kind of interest in gaming, y'all, I'm not a gamer. Maybe I become a gamer over time, but For me, the technical challenge that y'all sell is some of the largest, difficult, thorny issues there can be, right? Because we're talking about scale, we're talking about real time, and we're talking about global. And I think you start to mix those three things. I mean, there's a reason I work at Cockroach Labs. I love dealing with those problems too, and I think that's kind of the reason why this partnership has worked so much from really day one, Chris, right? And I think there's another kind of part of this that if I think about those three problems, but another big reason I joined Cockroach is just I'm a big advocate of open source. I got introduced to open source back in like 2007 or something. I was Talend and then Hortonworks. I've been at CoreOS. I just love these communities and I love what we do. What was it about open source that kind of drew you to this? Because it's a different approach. I mean, this is a pretty like rich industry, right, Chris? And open source is an interesting approach, right?
Yeah, so we weren't originally open source. So originally what we wanted to do was solve the problem as within what I would describe the backend as a service market. So think about it in terms of Parse or a couple of the other players in the space where you provide this out-of-the-box API for storing core data of some kind. I think Firebase is another good comparison in the space. And then you don't have to think about anything beyond interacting with the API. The underlying internal systems are working away, maybe doing some kind of optimization or tuning work to keep the system scaling for you. So originally we took that route into the market. But what we found was that when you're trying to solve something that fits into the core infrastructure category, which you guys know well at Cockroach, it really makes most sense to be distributing it as a product so that it can be customized and optimized to fit the specific situations that that particular player, in our case, game studios or game publishers are dealing with. But then secondarily to that, there's a freedom of ownership over the technology at that point that is somewhat necessary when people are putting at the heart of their applications something like database technology, or in our case, a game server. These are systems that are handling extremely important workloads and use cases that would otherwise mean that the game, in our case, the games would be non-functional. So we needed to give the technology to the market in a way that it was most comfortable to consume it. And that just looked like the way the last 10 years of the movement towards open source had shaped.
Yeah. And I've had this conversation a couple different times with people, Chris. It's like, I don't know of much infrastructure technology that's not open source anymore.
Exactly. Yes.
Like I'm trying to name what's a piece of open source technology, what's a piece of infrastructure technology that's not open source in the past, say, I don't know, 10, 11 years, I guess.
Within the past 10 years, I can't think of anything. Obviously, the quintessential example historically is Oracle, right? And that being a proprietary database engine. But anything in the last decade, I can't think of it.
Yeah, I know. And it's like, I guess VMware was kind of proprietary, but even that's kind of like open a little bit. But,
their hypervisor, their virtualization stuff.
Right.
Yeah, I think so. Yeah, definitely.
I think that was the last bit.
That was hardware driven in part as well, I think. So
right. It was a different equation. But I mean, to me, I don't know. I remember when open source was looked at as kind of like a negative, like, oh my God, it's not secure, like it doesn't work. Well, there were a lot of really crappy projects out there. I worked on one. It was called Hadoop. I'm sorry. I don't want to say anything too bad, but it was, man, that's a big burly code base of Java going on over there. But so, hey, but let's shift from open source. I'm going to come back to open source a little bit when we talk about Cockroach. And you guys are an amazing open source user of Cockroach Database. I definitely want to come back to that, but let's talk about Heroic Labs and what you all do. So the main product that you're all building, how do you say it, Chris? Is it Nakama? I presume there's like 15 different ways within your own meetings that this thing is said,
it's Nakama, and it's a Japanese word. It's a bit of Japanese slang for friends who are closer than family. And that kind of inspired, it was a motivation for the technology. We wanted to be able to provide a piece of game tech that could power extremely large social experiences. And so we wanted to be able to create or enable game teams to create player communities that you really did think about turning to that community for friends, and that they were people that you would form meaningful relationships with. So it's that was the reason we named it the way we did.
Yeah,
It was originally an internal code name, actually, but we were one of those companies that we got so used to referring to it that way that we thought we might as well make that the public product name. So
yeah, I mean, you know, you look at my first game was Pong, so I'm gonna age myself here, y'all. Like it was just flat out entertainment. You know, I'm a 2600 person. See, I was a gamer way back. You know what I mean? You know, I was 2600. You know, the PS2 was, I think, the end of my road. But I think that was kind of the advent of the social nature of games, and I think games are really truly social platforms, not really games. I mean, yeah, I think the game is kind of the vehicle to the social platform. Is that correct? Yeah.
So I think a perfect example for me is something like Words with Friends for the guys at Zynga. You play a 1v1 casual competitive gameplay, and you have friendships that form that mean that people have gotten married through meeting through that game.
Yeah.
And so that's what I mean when I say deep, meaningful social experiences. And you do it in a fun context. You've got some kind of gameplay, some kind of core game loop that is entertaining while you're meeting new people and forming friendships. So yeah.
Well, I love the name because it is apropos. It is absolutely.
Thank you.
And now that I understand it's Nakama, I can say it correctly. I think Cockroach Labs and Heroic Labs, we're Nakama. You know what I mean? We're close social circles. So.
Exactly. Yeah. In fact, I've spoken to Peter a lot in the past. We actually, my first look at the technology was back before it had a SQL engine on top of the KV store. I think it was back early 2000.
That is a long time ago, dude.
Yeah. So we've been following it for a long while, and we've grown together, I think.
Well, that's interesting. And you know, your experience kind of, you know, you have a database experience as well, Chris, from your past. I think, you know, Peter Mattis and Ben and Spencer, I think early days chose to be SQL, right? I mean, I think you were there before that, and you know, it was a big decision for them. I'm going to presume that your conversations impacted our decision to become what we are in many different ways, because I think
I'd like to think we had kind of a casual impact, you know, like just an ability to just riff on ideas. But I think they saw exactly what I had seen working at previous database companies at the time, which was that you would either adopt some kind of query language that was a standardized query language, or you would end up moving all of that into an ad hoc application layer problem.
Right.
We believe you guys chose the right path.
Yeah,
I think the proof is in the journey so far. Yeah.
Look, I'm a firm believer, and you know, you and I have had conversations about the document model versus SQL, and let's come back to that. Let's focus on Heroic. Let's get through. We've got a script here. Come on, guys. Like, you know, we'll get a little bit. I mean, you don't just show up ready to talk, dude. You know what I mean? So how many users how many users are using the platform? I mean, it's kind of weird to say like how many users are using Nakama, right? It's more like how many, I guess, customers, or how many instances are out there? How do you size it?
Yeah, we have a lot of customers. In terms of deployments, we think of the user base individual to each deployment. It's not a multi-tenant system. It's a per game type piece of technology. And as a result of that, one of the biggest games we work on at the moment has about 300 million players.
Right. Yeah. Somebody's asking, are we going to get to the scalable backend architecture? Yes, absolutely. I just wanted to we just wanted to go through this, y'all, just so we can get to I like open source. I'm sorry, y'all. I didn't mean to annoy people. But yeah, I wanted to get to kind of the size of it. So, and how many Docker downloads of Nakama at this point?
About just under 3.5 million downloads. Right. Yeah. So I think we think our community is in sort of like the 2 to 2.5 million range at the moment. Yeah.
Right. Okay, cool. And then another kind of, when I think about scale, I think about users, I think about, you know, size of an implementation, but I also think about geographic scale. And are customers using it today to kind of go global as well? I mean, you know, I think the single instance in a single region is an easy thing. Getting global is a wholly different problem, right?
Yeah, so for some game studios, I can't speak about the studios themselves, but in general, I can talk about it. We have game teams where we utilize the CockroachDB geotagging of data and geo-replication of information to be able to mark parts of the player base into a home region and then have secondaries replicated, cross region. And so we can create an audience that spans the globe. So it's a singular player base. We have the deployments of our game tech of Nakama per region. And then within that, multi-regional context, you've got the data replication, that core data that's part of the persistence layer that goes into CockroachDB that's being replicated. And we depend on Cockroach to do all of that work.
Yeah. Right. So how much of your stack are you comfortable talking about, Chris and Tom, in terms of like what you guys pulled together to do this, right? Because what you're doing is promising a backend infrastructure for someone who just wants to build a game, right? You just want it to be, you want people to basically build what they dream. We're the same way, right?
Yeah.
And so what does the backend stack look like for you guys?
Okay, so it's all provisioned on top of Kubernetes.
Okay.
We try to treat our deployments as a cloud within a cloud. So we try to create agnosticism from the cloud platform that we're within. So it could be on Microsoft Azure, it could be on AWS, it could be on Google Cloud Platform. We don't particularly care because we think of the cloud as starting the boundary of our cloud platform and our components when deployed is starting at the Kubernetes level. Mm-hmm. And so we have the usual ingress controllers, stateful sets, all of those elements that go into operationalizing this stuff in a high availability capacity. And that means running CockroachDB clusters for all of the core data and persistence, and then handling our game server tech, clustering our game tech. And we could talk a bit about what that means later on. And the two together become their own independent scaling units, depending on whether a game is IOPS heavy or maybe real-time heavy, where they might be handling socket connectivity. And that's where we balance the two together. And that gives game studios the ability to get that high availability, fault tolerance, the scale out, and some amount of elasticity. Less elasticity at the CockroachDB level, because as you amass hundreds of gigabytes of data, moving that data around becomes much more difficult. Scaling in is harder, and that's okay because there's more just resident data on disk to have to move. But there's some elasticity there as well. And that's just what we think about at a regional level. And then multi-regionally, we've got regional deployments of the game tech, and then a multi-regional deployment of Cockroach.
Right. So you basically have the game tech layer, you have Cockroach as a database. What else are you using within the game tech layer that actually helps you scale? If we talk about, is there other kind of packaged open source projects that you guys are depending on? Beyond Kubernetes, I want to come back to that because I want to talk about, how you guys actually think about Heroic. Is it Heroic Cloud? I'm sorry, I totally.
Heroic Cloud.
Yeah.
So, at the cloud layer, okay, so beyond the Kubernetes, other components that go in, we're big users of gRPC, Google's RPC framework, protocol buffers as a result of that. We work in Go, exclusively in Go for all of the systems that we build. Mm-hmm. And then we have built our own gossip layer, bunch of replicated data types that we build that converge across a mesh network. So we have tried to create a lot of the technology we need internally to achieve scale out so that we can create this incredibly operationally simple model for game teams to use. You just simply deploy the Nakama clustering tech, you deploy CockroachDB, you scale each unit as you need to as you grow. And that is a pattern that doesn't change. And you just point a load balancer at it, load balance requests across any of the nodes in the Nakama cluster, and that becomes the model for success.
Yeah. And it's interesting. You talked about GPRC with Kubernetes, CockroachDB. Are you guys also using things like Prometheus and OpenTelemetry? Or?
Yep, absolutely. Yeah. Prometheus on the internal side of things for monitoring. We use FluentD for log capture, bits and pieces like that. Yeah, we use a lot of open source pieces within our infrastructure. Yeah.
And have you guys gone down the OpenTelemetry path yet, or at least open tracing?
We actually we jumped. We didn't like the shift between open tracing and the newer, I can't remember.
OpenTelemetry. Yeah.
OpenTelemetry. And then there was the other one, OpenCensus, I think. So OpenCensus merged with OpenTelemetry telemetry into whatever's the latest and greatest thing open tracing into open telemetry. Anyway,
Right.
we haven't jumped onto that ship yet. Instead, we just picked up a library that the Uber guys had made available, that fantastic little library called Tally, and that does all the heavy lifting from our metrics capture at this stage. So yeah.
Right. That's awesome. Yeah. There's there continues to be massive, huge libraries come out of like these large kind of distributed, scalable backend systems. Like, so if somebody's asking about how do you actually build these things, I think, getting into those architecture documents that are published on blogs at like Uber, Lyft.
Yeah.
Our friends at Netflix do a lot of this work, right? And getting into that, I think that's where I find a lot of the stuff. I'm friends with a team that helped build Michelangelo. They're building something called Tectonic, right? It's a backend library to do ML ops, and it's like, you want to figure out how these people do this stuff, go read their blogs, because there's some really great information out there and some really amazing open source projects, or just not even open source, just libraries.
Absolutely.
Right?
Yeah.
So, but it's good to see fellow kind of Go people out there. But I guess one of the things that I'm hearing about from you, Chris, just in your choice of technology, is kind of ease of integration with everything else, and built on the same core principles of kind of what I think of as like distributed systems. I mean, this is just truly, you can't do this without distributed systems, right?
You're absolutely right. We were originally an Erlang team. So if I could have taken the Erlang distributed runtime and used that directly, we would have done. We couldn't, because you can't easily hire Erlang engineers.
Well, yeah.
And if you can, they're all at Facebook working on WhatsApp. So instead, we looked at other languages that had a similar kind of set of core primitives for, lightweight threading, Go routines in this case,
Yep.
Erlang processes, if you want to call them that in Erlang terms. And then we ended up building up what is effectively something somewhat similar to the Erlang distributed runtime inside our game server tech. Yeah. So that's why we scale the way we do. Yeah.
It's funny. I taught myself Go about a year and a half ago, and it's kind of one of these things that once you see it, you can't unsee it.
Yeah.
It's once you write. Tom, how long have you been coding in Go?
I've been coding in Go for about 2.5 months. So
Wow.
I definitely concur with that. I mean, before I joined Heroic, I was completely JavaScript and C#. So moving across to Go has been, it's been a challenge, but it's one of these things. All the guys keep saying to me, as soon as you go to Go right, you'll never go back. It's one of these things, you'll become an absolute convert. But it's massively different from your typical sort of programming language, definitely.
It's just it's strangely enough, it's just a very simple language. It strips a lot back.
It really is.
You don't need to think about creating objects and thinking about facade patterns and factory patterns and things like that. It just strips a lot of that away. But you do get this fantastic concurrent runtime, and that's the key to its success.
Once you get around the syntax, I think it's like you say, there's a lot of flexibility and freedom there for sure.
And that was my big problem, Tom. It was the syntax, honestly. But I'm also sad to see Jakobson go away, because I like my object patterns. Sorry, guys, but again. Anyway, coming back, but when you start to think about scale, you start to think about infrastructure. The reason I like to focus on tools is to help people understand, like, these are the things that are happening in the industry that help people build this type of thing, like this global scale thing, or any sort of scale, is going to be predicated on certain technologies. And honestly, the language itself is amenable to scale. Like, Go as a language is directly amenable to scale. So like, code on it, learn it. And I think, to me, it's the language of the future, honestly. But it's kind of one of these things, I don't know, Tom, like when I first learned Go, it was, I always think of Google products as being like half done, or like 80% done. Because like, there's like that 20%, if they just did this, it would be a little bit easier. But once you get into the mindset of how it works, you're there, right? Like, I think
that's it. I think it's unlearning some of the patterns that you've become familiar with other languages and things like that. So but I totally see what you're saying. But absolutely. I think I try to do everything I can in Go at the minute. Obviously, we support multiple runtime languages, but I'm definitely trying to stick with that, just because it does seem to be so flexible, so powerful. So
well, cool. Let's get into a little bit about Cockroach. Thanks for going off road with me a little bit, you guys. I like talking about Go as a language, honestly. So
Good.
Let's come back to Cockroach and kind of how you guys are using us. I know Chris, you had found us early on, and you kind of went through the decision of you wanted SQL in a database, right? I mean, that was kind of like a requirement for you up front, right?
Yeah, we looked at when we were evaluating how to rebuild some of our technology from being a service model into being a product. We looked at database technologies in the market. We did a bit of a survey of it. We settled on there was a document store that was out there in the space that we looked at, RethinkDB, and we looked at CockroachDB. And having spent some time in the database space myself, teaching developers and the right kind of application data models and how to think about modeling at the application layer level, I just wanted to return to SQL because I believe, and I still hold this belief, that there's 20 years worth of knowledge that has been accumulated in how to interact with data sets and data problems through a SQL interface, through a SQL engine. And I think that knowledge still has plenty of room to be grown and to grow and be leveraged. So that's why we chose that. And so when it came to building out the schema for our tech, it's all open source on GitHub. You can see the schema that is directly utilized by Cockroach. We used some patterns that were popular at the time for social networking. So for example, the guys at Twitter had worked on a sharded MySQL application layer piece of technology that they had called FlockDB. It was written in Scala at the time, but it used this adjacency list model that sat on top of MySQL that used sharding keys to figure out which shard to go to, that would store that vast amount of information that went into the social graph. And we adopted that similar design pattern and adjusted it to fit on top of Cockroach. And so when it came to building out kind of social graph systems like friend lists, like guild systems, talking about, show me friends of my friends who are not yet my friends, sort of friend recommendation or guild recommendation, sort of components that fit perfectly well in a social network, but also are deeply important to social gaming. It became really easy to express those. And so we developed it with that kind of model in mind. Yeah.
And to express them at scale, I think is the trick, right? Like, it's like, sure, I think the document model can work, but to actually see it laid out in schema, I think it just makes it a lot easier to deal with these sort of things. It's a really good example. We see other customers using us for the same sort of thing, Chris. It's like this social graph stuff. Interesting enough, I thought it was a simple problem. It's simply not. And by the way, 20 years of SQL, it's like 40 to 45 years of SQL.
Yeah, you're right.
You know what I mean?
You're right. But I mean, 20 years worth of recent SQL, where the SQL standards were a little bit more modern and the flexibility was, a little bit more, less rigid. Yeah.
And I think we see a lot of the same thing. And we talked a little bit about this too, Chris. You're going to use the right tool for the right job, right? I know you guys are using Cockroach. Are you using any other databases for kind of distribution? No. You're using all Cockroach.
Everything, all core data lives in CRDB. Everything that is real-time data that comes as part of socket connectivity happening within the game server instances is managed in memory and replicated through our own clustering technology.
Interesting.
So we have, there's a way of looking at our technology where if you were to put sort of rose-tinted glasses on or something like that, it would look like an in-memory distributed database pretending to be a game server. That's sort of how we approached the problem when it came to solving it. And by creating that replication model, we could, do fast traversals of, which socket connection is where across the cluster to be able to route chat messages and things like that. And that becomes the system for real time. And then everything that's core data lives in Cockroach.
But
user accounts. Sorry, go on.
No. You just said something that I want to pick up on, Chris.
Go for it.
And I think this is like, how do you build something scalable back in there? A system, like you want to build a product. You just said this is an in-memory database that looks like a game server.
Yeah. That is the truth. Yeah.
And it's true. And I think if people start thinking about their applications as this is a in memory, blah, 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 or whatever, like if you reverse the approach and the way that you look at your, whatever it is you want to do, I think that's the appropriate way, right?
We definitely flip the problem space on its head. And I don't know whether this is something that is the right way for game teams that might be building their own infrastructure internally to be able to think about solving this problem. We did have some experience, particularly obviously in my background and some of the rest of the team in building databases. So that did make a difference in the way we modeled out the problem. But by flipping it on its head, you could almost imagine it in sort of a microservices architecture, but it's a homogeneous topology. So it doesn't matter which Nakama node you're talking to in the mesh network. Any one of them can serve a friend request or a user account lookup or authentication call or anything like that. So it's a microservices pattern in that sense, but all homogeneous. And again, it was designed this way so that you limit the amount of discrete separate services you have to build and manage to create a successful game at scale. That was our philosophy anyway.
Yeah, and I think to me, it's the right philosophy. I mean, just having these discrete services, all of which can actually serve as to take on some sort of request, like, and that's your scalable unit, like getting down to this atomic unit that is of scale. I think it's just one of those core principles of distributed systems that I think once you get it, again, this is one of those things. Once you see it, you can't unsee that.
Yeah. But it's not for to be fair, it's not for the faint-hearted, and it doesn't necessarily mean that we don't depend on all core data to live inside something that we pull in database technology, we pull in CockroachDB, and we depend on it for its core principles, and that's the referential integrity, that's the transaction support, all the transaction semantics, ACID compliant, all of those things, we do depend on them. By establishing foreign key relationships between pieces of data, between users and leaderboard records and everything else, we can efficiently serve aggregate queries that form GDPR export requests or, GDPR, right to be forgotten, deletes, that kind of thing. So we definitely depend on not having to track references ourselves between some data living in this location needs to now be matched up with data living in some other location so that we can aggregate it for some kind of final result.
You could possibly do that with the document model, but you're going to add complexity to the application layer. Like it's like, again, like thinking of your problem space and what you actually want to accomplish and using the right tools within that, to me, has always been that's how you kind of go about these choices. I'd ask you what data is being served in Cockroach. It's typically, but it's like all of it.
It's all of it, yeah. But, it's leaderboards, leaderboard records, user accounts, social sign-ins, the social, tokens, that kind of thing. Friends lists. So this, we talked about the adjacency list model that we map over the top of the table structure in Cockroach that powers the social graph. All core data lives in the data set.
Well, now I'm intrigued. I'm going to go check out the data model. I want to actually see this thing. So I'll check out your Git repo.
Yeah, it's all there.
Yeah. And I love that it's all there. And again, this comes back to where we started, Chris, about being open and open source. I mean, were you afraid of exposing any of that stuff? I mean, what you guys are doing, I always think it's important to expose these things because I think it helps everybody get better. Did you have any concerns about kind of exposing that sort of stuff publicly?
I think the games industry historically has operated on a closed source product model.
Yeah.
So, you might license the Havoc physics engine, or you might license Unity engine, or you might license Unreal Engine. So maybe sort of like, we've been in this space a while now, but maybe 5 years ago, it was, odd. And that's why we spent quite a while debating about whether open source is the right approach to take with the way we wanted to productize the tech that we would provide to game teams. But in the end, it's core infrastructure. So I want game teams to have the freedom to look under the hood and say, okay, this is how this works. And they can contribute back to the technology. And if they need to take it in another direction, that they could, So we ended up realizing we couldn't present it without being open source, even if the games market as a whole hadn't yet kind of wholly embraced open source for things. By now, everyone's on Kubernetes, everyone's utilizing Prometheus. So the industry is quite different now.
Well, not everybody, but a lot of people, a lot more than
a lot of teams that we work with. Yeah, a lot of teams.
Exactly. That we work with. I know. My social circle is all on Kubernetes too, basically. You know what I mean? Like it's kind of moved in that direction, and it seems to want. I quite like Nomad as a more simplistic form, but hey, I think the Kubernetes thing in the community, I think the community is really what's been driving
Yeah,
this
yeah,
larger scale adoption. I think it's important, and just the kind of the open source ethos as well, Chris. And one of the reasons you chose Cockroach again is the open source license, right? I mean, all of this is
yes,
being done on
yes.
CockroachDB core, correct?
Yeah, yeah, it's all on Cockroach Core. Yeah,
Yeah.
yeah.
And so, I think 2 years ago, we changed our license model. We went from GPL2 to BSL. Did you guys have any concerns about that? Just to kind of tie off on that point.
No, we didn't, because we understood the motivation for it. And the motivation for it was that it was, I believe, to protect the company from cloud providers who wanted to, wrap up the technology with a proprietary wrapper and then, make it some kind of package service in the cloud. And, obviously, I'm uniquely positioned in that I had a lot of history working at database companies before, where we firsthand saw, what happened to players like Elasticsearch in the market, and what damage or not, what impact that had. And so I understood the motivation, and it doesn't affect us. And I don't believe it has had any impact on the way that game teams use our tech.
Yeah. And just to be fair, Chris, we took a lot of concern. I know, our founders were intricately involved in, you're a founder. I mean, you understand what these are big decisions.
Yeah.
And, to go through this and actually do what we did, was it a risk to the business? Sure. But was it right to do at the time? Yes. What we wanted to do is make sure we had a license that allowed something like Heroic Labs to continue distributing our software and continue to build platforms on top of it. None of that goes away. None of that goes away.
Yeah. Yeah.
And it's funny how like the like open source zealots are like, oh my God, it's not an OSI approved license, that it's not open source. It is all of the things of open source minus one provision, which is let's protect basically the core group of people who are building these things and trying to make these things happen, right? Like, because there's momentum has to build. And, to me, the curation of that momentum, I think, is pretty important. I think the HashiCorp team has done a good job with this over the past couple of years, right?
They've done something similar. Redis has done something similar. I think Mongo at one stage changed their licensing model. I think it's part of a natural evolution of open source to make sure that the core creators of some of the technology can still take the opportunity to realize the outcome.
Well, I think it's just one of these things. I think these open source communities get it, and I think who will live and work in them understand these kind of nuances of what's actually really happening. So, thank you for being such a great advocate and kind of, making sure these things work.
No problem. You're welcome.
So scale is not easy. And I'll put you on the spot. Like, if there's kind of three things that you think about, or if there's like the core things that you guys think about when it comes to scale, I don't know, like what's a takeaway for the audience? Like what are the things they really got to be thinking about when it comes to scale?
Okay, I'll talk about it in the context of CRDB, some of the challenges we've seen over the years. And then hopefully that will help inform game teams, producers, big studios who want to leverage the tech and leverage the database tech directly. Give them takeaways. So one area that's always a challenge is garbage collection, right? Now you think about garbage collection at the programming language level, you don't often think about it at the database level, but you will have to tune some of these parameters to be able to keep up with the kind of write workloads, particularly with how a lot of game teams will store some core piece of game data. Let's call it the player save file or something, save progress. They will take it out of the game engine, create it as a tree structure. It will be serialized to JSON usually, and then they'll want to write that. And so they'll be writing that very, very frequently. You end up getting very hot rows. And you get hot rows within the database, primarily because obviously to maintain the transactional compliance that you'd expect, the SQL engine has to keep a track of which versions of that particular data are live at any given time, right? So you have multiple versions, row versions of the same record that might be on disk. Well, you need to figure out how to tune to make sure you're keeping up with processing and clearing out old row versions that you don't need anymore.
Yeah.
And so it takes a little bit of skill to get that tuning right. I know that Cockroach has done huge amounts in a lot of areas to make that better over time, obviously, to end up with more out of the box defaults that make sense for large, complex OLTP workloads. So I've been doing a really good job about that. But that's one area that you'll have to know a little bit about the underlying details in the way the row versioning is managed by CRDB to be able to optimize that. For this kind of game use case, definitely.
Well, yeah, one of the things we always talk about with customers when they're new to something like Cockroach, it's distributed systems are a different way of thinking. It's distributed thinking, right? And I think that's one of those things, like when you start to actually realize how the backend storage layer works, well, you want to use UUIDs. You can't use sequential IDs, right? Like you got to start to understand what hot ranges are. You didn't know what that is. I was on with Sean from DoorDash. DoorDash has been a great customer of ours as well, and doing some great things. And he's like, yeah, like if you're going to insert 10,000 records in the database, do you do one insert command or do you spread that out across 10 of them in different places? And, like, how do you, like, as a developer, you have to think differently about these sort of things as well, right?
Yeah. I mean, UUIDs is a great example because, one argument is, well, I should really be storing this data that represents the player uniquely in 8 bytes, and I have to take on 16 bytes because it's a UUID. And so I'm, wasting storage space. But the counterpoint to this is you get to be able to handle a scale out model so that you're not creating hotspots through some kind of primary node that is having to issue the next auto incrementing identifier along.
That's right.
So you don't end up in that hotspot model. But there is actually a secondary benefit that comes out, particularly in gaming, which is pretty interesting when you're using UUID v4 in particular, because it's a pseudo randomly generated identifier. You can dive into a data set using kind of key set where clauses that dive straight into the positioning on the B-tree index and end up range scanning, say 100 or 150 pseudo randomly selected user accounts, which works really well when you're trying to then kind of do a little bit of in-memory filtering to say, hey, find me 10 other opponents that I could play against. So you can actually turn the consequence of storing it with UUIDs into a benefit in the way you design your APIs. So that's something we've done.
And that's awesome. And that's not something on day one.
No, it's not. Yeah, it's
no,
not. Yeah,
it's just not something And I think it's becoming, it's the shift to distributed and how that actually affects the way you think about not just what you're doing, but the logic and the business outcomes of what you're trying to produce. Yes. We see it time and time again, dude. And it's just great. So, so you guys, you have a growing team. I mean, you have, a great set of customers. What's next for Heroic Labs, Chris?
What's next for us is actually building a bunch of analytics and player personalization systems that will be a separate piece of technology to our core game server tech. And that stuff will also be built on Cockroach. So, so we're experimenting in sort of that, analytics workload rather than your transactional workload. Yeah. So your OLTP into your OLAP workloads. So that's a new place for us to explore to help larger game teams tackle deep player personalization when it comes to game tuning and things like that.
A fundamentally different problem. It's
fundamentally different. Yeah, it is.
Yeah. And it's funny internally. We have a lot of conversations about this. What are the analytical type queries that we should enable within Cockroach that are going to allow, this basic type of stuff. Like, will we ever be a data warehouse? I don't think so. Maybe 10 years or it's not. There's a fundamental approach in the architecture of the database itself that requires you to make changes to be that, right? And I think that's the, to me,
But there's a vast amount of, particularly with our kinds of workloads, there's a vast amount that we can do in the existing design model, but we do know it at the storage engine level at this point. We've been following Cockroach a long time, so we know how to eke out the best out of the way the query engine will end up translating it to disk reads. So
Yep. And again, it's just one of these things, Chris, like you got to know kind of how the architecture of the tool that you're working with to optimize and use it for the right purpose. It just comes back to that. We do this architecture talk a lot because it's actually pretty important for you to understand how the actual thing works. Like We're talking about primary queries. We're talking about like, what are the analytical queries? Like, yeah, we implemented vectorized query, right? Well, that's going to allow you to do X, Y, and Z. You got to understand kind of what it can and can't do for you. I think is what are the limitations of whatever tools you're going to build your platform from. So
yeah, I mean that's kind of pure engineering principles. Ultimately, end up with every single decision you make is going to be a trade-off, and that's not a bad thing. It's just a natural order of engineering any problem. Yeah,
it's pragmatic and an engineering approach to what it is, right? Exactly. Yeah. It's funny there's a lot of talk with analysts about like, oh, it's going to consolidate down into one platform. I'm like, bull. Like I don't believe in the one platform. I never will believe in the one platform. Sure, maybe there's like a storage layer that has everything in it, but you're going to have different tools that are going to be always used. I don't know. Like,
I mean, within the database space, there's definitely room for multiple engines solve specific problems differently.
Yeah.
You know, column stores are always going to have their place, I think, in the space. Graph stores. I mean, interestingly, we haven't needed a graph store to solve the particular type of social queries we do in the game server. But for more complex graph traversal, you would absolutely need to think about it beyond looking at adjacency lists as a way to store data. So
yeah. Well, cool. Well, thanks, guys. I think we covered pretty much everything that was in our little list over here. Probably was a couple bullets here that we didn't hit, but I really, really appreciate you all doing this. And seriously, I appreciate you being advocates of Cockroach Database. I know you guys are using the, CockroachDB core. It's, free to you. We try to continue to add more and more features into core every single release because, there's people out there using it in production on some massive, huge systems. So, thank you for doing this today, Chris and Tom, and I really, really appreciate it.
No problem. Thank you for having us on.
Thanks for having us.
All right, y'all. Again, a recording will be available relatively soon here up online. I hope everybody enjoyed this. There's be a survey will pop up for anybody who was on the online version of it. And we do take these things serious. I know there were some questions about, oh man, can you get to the scalable backend architecture? I hope I directed it in that direction a little bit more without, charts and graphs, but you can go check out the Git repo for Heroic Labs, and you're going to see a PhD in kind of distributed systems and how to do scale. I mean, right? Like, come on, Chris.
You'll see some elements of an in-memory database. Yeah.
Well, exactly. I always talk about the Cockroach data. The Cockroach code base is kind of a PhD in distributed systems. There's some cool software engineering out there, and it's all open, and you can go follow things out. So. Cool. Well, thanks, guys. Enjoy your day, and everybody enjoy their day, and see y'all later.
Thank you so much.